Operation Sandstone. In October of 1947, engineer units which had been selected as a vital component of Operation Sandstone were alerted. Time became the governing factor to meet deadlines established for the first detonation of an atomic weapon at the recently created Pacific Proving Ground, Eniwetok Atoll. Swift, coordinated planning enabled supply units to set up an exacting schedule for loading and delivery of equipment and material to the test area. As plans were swiftly completed, a steady flow of necessary material to implement the project began to arrive at two West Coast ports for shipment to the proving grounds. Support and execution of the operation called for the assembly of a wide variety of supplies. Chief problem in the shipment of needed gear was posed by the handling of heavy machinery. But the engineers executed this phase with their customary speed and skill. Selected personnel were screened by the Federal Bureau of Investigation, then thoroughly briefed as to their specific duties during the project. Arriving at a West Coast port by train and bus, the troops were checked aboard transports for movement to the proving ground at Eniwetok Atoll. As troops boarded ship in the United States, advance echelon personnel from stations in Hawaii were engaged in rehabilitation of installations which had not been used since the close of World War II. While the troops were en route, civilian teams working under contract with the engineers were establishing a base reference point pylon in the lagoon to determine measurements for all installation sites set up for the tests. First troops reached the proving ground on November 28th, the main body arriving on December 24, Christmas Eve. Swiftly, the ships were unloaded. Equipment and supplies were distributed to strategic points on islands of the atoll by Navy and engineers' small boats and LSTs. As heavy equipment was moved to the area of action, preparation of sites was begun. Underwater obstacles were blasted so that boats would have easy access to the beaches. Thousands of palm trees were removed so that photographic and visual observation of the blast would be uninterrupted. This was essential, as the most precise measurements were to be made of the detonations. In order to build, the engineers were first required to destroy. Obsolete and weather-weary structures had to be cleared from the vicinity of the detonation points. Though it would appear that many of the buildings were still serviceable, inspection revealed that their usefulness had been destroyed by the ravages of wind, rain, and sand. Paths along which blast analysis instruments were to be placed must be rid of buildings, trees. While some of the engineers were engaged in preparing the test sites, other construction troops were toiling at the building of living quarters on Kwajalein, housing to shelter Air Force personnel based on the island. The erection of new facilities made necessary the expansion of water and sewer installations. Engineers had anticipated this demand and necessary equipment was on hand. Warehouse floor space in existence was found inadequate for sandstone demands, so new storehouses were quickly erected. At Eniwetok, the tremendously increased demand for electric current posed yet another task to the construction men. Decommissioned generators were in many cases rehabilitated and placed in operation. Roads which had fallen into disrepair through a long period of not being used were soon back in usable condition as preparations sped ahead. Aggregate used in repair was obtained on the islands. As clearing of test sites was completed, surveyors began to locate points for blast structures. Constant wind was a sore trial to the men as they sought to make accurate measurements. But ingenuity produced windbreaks, and measuring tapes were no longer wind-whipped. Dust and wind were relentless as the men toiled in the broiling tropic sun. Heat and blowing sand were a constant source of irritation to the troops. Nevertheless, their progress was steady. The readily available ingenuity, hallmark of all engineer personnel, was evident everywhere. When proper equipment was not at hand, the troops improvised. Here, a chute made of old sheet metal for delivering asphalt into trucks. Always, machines were supplemented by muscle power supplied by the men. Possibility of instruments being damaged by blowing sand was minimized through soil stabilization, done by oiling and turning the shifting sandy surface. This later proved to have greatly reduced ground dust incident to the blasts. Specifications called for scores of concrete structures, so the engineers established a central form shop. Even though confusion seemed the order of each day, it was actually a well-ordered system that resulted in swift and steady progress. Transportation costs were saved and valuable shipping space conserved through the use by the engineers of coral aggregate as a basic ingredient of the needed concrete. Tests showed that the local material was of sufficient quality to serve the needs of the construction program. Nuts and bolts and washers were mixed with limonite ore and cement for the construction of the gamma stations. This strange mixture called for by the scientific plan made walls strongly resistant to penetration by gamma rays. Careful weighing and measuring of ingredients was observed through the mixing process, supervised by an expert in concrete work who checked every step of the construction operation. The inclusion in the aggregate of the washers, bolts, and nuts, together with the limonite ore and cement, considerably changed the time necessary for the mixture to set properly. As the result of tests conducted on the scene by the engineers, it was found that the setting time could be controlled by the addition of small amounts of sugar to the mix. In this manner, the construction men were able to complete their structures in accordance with the exacting timetables set up for the operation. So again, the hard-headed, in-the-field resourcefulness of the engineers came to the fore in enabling them to adhere to the schedule despite unexpected interruptions. So that the concrete used would conform in quality to the exacting specifications called for in the plans, a concrete control laboratory was set up. Reinforcing metal was erected and welded together to further strengthen concrete blast structures. Pouring of concrete for the blast-proof structures followed close on the heels of the placing of reinforcing steel. Dust and wind and sun, choking, blinding clouds of cement and sand persistently harried the construction men. The light plane ferry service, which knit the separate islands of the atoll into a readily accessible network, were dependent upon the engineers for operating facilities. With their customary ingenuity, the construction men used material at hand. Here, pierced metal plank, laid during the war, was cut and moved to make parking areas, landing strips, and working platforms for the small planes. Operation of the small aircraft was also an engineer function. Landing strips had to be built on all but 2 of the islands. Where necessary, engineers felled trees, filled depressions, or graded land to construct the strips. Foundations for the Zero Towers were completed by New Year's Day. Civilian steelmen who worked with the engineers erected the first tower in 9 days. The others were completed soon thereafter in an equally brief time. A dress rehearsal had been held in the United States, which sped the erection of the towers at the test site. Photographic towers, which would house batteries of cameras to record developing phases of the blast, were constructed on 3 of the islands of the atoll. From this rolling, pitching barge, a 4th tower was constructed on a coral head in the lagoon. Despite adverse conditions, civilians with the engineers raised this sturdy, isolated structure. Limited landmass of one of the selected test islands created a major problem for both engineers and scientists. It was deemed necessary that a causeway be constructed to join this test island with a neighboring island across a 700-foot wide channel, despite a steady 4-knot current through the gap. Made by driving sheet piling and filling the space between with sand, the link was built from both ends and joined. Here again, civilian workers with the Army proved their worth by constructing this essential structure. Engineers dug the ditches to hold basic cables, virtual spinal cords of the blast study installations. With the laying completed, graders swiftly covered the sensitive electric carriers. Assembly of the coaxial cables was carried out with the assistance of engineer troops under the direction of Atomic Energy Commission scientists. These coaxial cables were to be used in one of the most important of the several experiments carried out during the detonations. They connected the tower with the timing station at the opposite end of the island, far down the line of blast measurement installations which stretched along the cleared blast path. Remote from the detonation point, the timing station was the site for recording instruments of prime importance in determining the efficiency of the atomic weapons which were to be tested at the proving ground. The timing station was not thought to be completely resistant to gamma penetration. To protect recording instruments against radiation so that they would only register phenomena by means of signals carried along the coaxial cable, the oscilloscopes were enclosed by a coffin made of lead bricks. Test findings later disclosed that the coffin actually was unnecessary, the station itself providing adequate protection. A second method of stabilizing the coral sand, which made up the majority of the surface of the test islands, required the engineers to use soil cement, an earth-bonding material which was applied to the area surrounding the second and third detonation sites. After the soil cement had been strewn by shovel, it was mixed with the sand through the blending effects of a disc harrow. The treated surface was then given a preliminary leveling with the device created on the spot by the ingenious engineers. Once the area under treatment had been leveled, rollers were brought into play as a final smoother. In some instances, requirements were so precise that hand tamping was used so that surface bonding would not exceed or fall short of specifications. This method of soil stabilization was developed by engineers during the war for swift construction of airstrips, roads, and parking areas. When the main body arrived in mid-March, all foundations and basic structures were complete. Engineer boat units were part of the pool of small craft which were of great aid in expediting delivery between islands and from ship to shore of personnel, material, and equipment. When the scientists came ashore, they found everything in readiness for the final installations, last-minute checks. Security guards registered every single person arriving at the test islands. Directed by the scientists, the troops turned to the more exacting task of installing blast measuring devices within precise limitations. Engineers set up many of the instruments, as they too were deeply interested in obtaining blast pressure data during the test. As work was progressing on the test islands, other engineer crews had constructed the master control station. From this structure would be flashed the electronic impulse which would detonate the atomic weapons. Here, too, records of the blast would be made. Although working at a swift pace all day, the engineers could exert additional speed when it came time for that good food. Presto, abracadabra, what more magic word than chow? Food was of excellent quality and plentiful. Napoleon said an army marched on its stomach. The engineers produced tremendous amounts of work, in large part on their stomachs. Although the pressure of work on the men seemed constant, there were moments when they were afforded an opportunity to relax. Ample recreation facilities were at hand. Regardless of the urgency of work at hand, the men were regularly afforded an opportunity to attend religious services of their particular faith. They were also given time to go to special observances. The Corps of Engineers itself made reinforced concrete structures for evaluation of blast effects. Some of these installations were sealed. Others were left open, with the openings placed facing the blast. Some turned at an angle, while still others faced away from the explosion. By now, blast-proof structures had been completed. Shadow or deflection effect of earth barriers was also of major interest to the engineers. Gauges to measure pressure were placed close to a bunker made of local material. The instruments were set up on the side away from the detonation point. Meanwhile, at Eniwetok, the engineers were busy preparing an arresting gear for the drone planes in the event that electronic controls might fail. Dead men were sunk in the ground to anchor steel cables. To the steel cables, nylon rope was attached. This rope, stretched across the end of the runway, would engage a hook specially installed at the rear of the drone plane. Stop it in the event brakes failed. To test the arresting gear, a drone plane carrying a safety crew was landed, allowed to run into the nylon rope and steel cable arrestor. Should the nylon rope fail, a last resort was to be a ditch which would catch the landing gear of the plane. Revetments to protect landed drones from those still landing were made of war debris and wreckage available on Eniwetok Island. For 5 hours prior to the drone plane's takeoff, engineers poured 14,000 gallons of water on the coral runway to eliminate dust which might hamper operations. As the deadline for the first test approaches, instrument protectors are sealed to shield measuring devices from radiation effects. The closure is completed with the placing of the final lead brick. Indication that all is ready is seen in the closing and sealing of timing station doors. The first blast only hours away, the site is ready. All personnel are checked to see that everyone leaves the island. Every single man must be accounted for aboard transports which will depart from the lagoon until after the blast. For the first time since their arrival at the proving ground, the engineers have an opportunity to relax on a working day. Ready, the island lies silent, waiting. As the swift tropical night closes in, all personnel are tensely awaiting the detonation. The 0 hour is at hand. The first test has been completed. Yoke blast, second of the test, was successful. Third and final test, zebra blast, went off on schedule. The engineers had performed prodigies of labor to make Operation Sandstone a success. Yes, prodigies is right. For in a few short months, they had cleared hundreds of acres of palm trees. More than 100,000 square yards of coral sand were paved or oiled to stabilize the soil. Thousands of cubic yards of special concrete were made and poured. More than 200 tons of reinforcing steel were placed. Thousands of cubic yards of coral aggregate were quarried. Test cubes ranging in weight from 3 to 6 tons were moved and located. And 7 light plane landing strips were constructed. Yes, the engineers may be sure that their efforts as a part of Joint Task Force 7 deserve only the highest praise, were worthy of sincere commendation.